Okay, so let's get started. We're going to be taking a look at working with idle stepper motors in our idle control routine programming found within our Link G5 and G4X systems. Now, our idle stepper motors differ from a pulse width modulated motor that we talked about in that last training module mechanically. So the solenoid itself is going to do the same thing. So we're essentially having a controlled vacuum leak. But instead of having a valve that's pulse width modulated duty cycle control, we'll find that we have this stepper style control. And essentially what's happening is we have a screw mechanism. And each time the screw turns, it's going to count as a step. There's going to be a finite amount of steps that the stepper motor is going to have. So for example, if you're talking about a 2JZ engine with a stepper motor fitted from Toyota, that's going to have 200 steps. If you're talking about a 4G63 engine, you'll find that has 140 steps. If you're talking about an LS-based engine, those can have 310 steps. So different stepper motors will have a different step range or amount of times it can turn to open or close to allow an airflow leak into the engine. Now, the goal of working with the stepper motor in the idle control routine is to allow airflow or additional airflow to come into the engine to allow it to compensate for things like cold start or when a cooling fan turns on or when the air conditioning turns on. We'll have a torque loss, either frictional or a low drag on the engine. And as a result of having that low drag or that frictional loss, we lose torque. We need to gain some of that torque back. We use airflow to gain the torque back in those unique specific situations. So we'll find that the stepper motor in terms of functionality differs in the control for the programming in terms of obviously working and moving that stepper motor open or close in the number of steps, but conceptually works the same as a pulse width modulated type of control, meaning we're going to be moving more or less air into the engine under various conditions to have a certain amount of idle torque to get to a certain amount of idle speed. We talked about this concept in our idle basics tutorial. Ultimately, what we're doing within the idle control tuning is controlling the engine's torque. We're going to be finding that we have airflow as a means of controlling torque as well as spark timing. There's going to be two different options. We have the airflow, which would be slow path of control. The spark timing is fast path of control in our engine's torque production at idle. Generally, we want the stepper motor to do very little in terms of movement at idle. We want it to be a relatively slow moving kind of coarse type of adjustment in the idle control. The spark timing is going to be very, very quick, very dynamic in its feedback to control the engine's torque. So that's the overall strategy. Just as we found with pulse width modulated solenoids, the idle stepper motor solenoid are going to be controlled the same type of idea in terms of the concept, but the way we work with it is just a little bit different. So let's jump in and take a look at some of these differences for our programming. Now, you may have skipped the pulse width modulated tutorial completely, so we're going to go over a lot of what we talked about here in the beginning of this tutorial as what we discussed in that pulse width modulated tutorial. I'm going to assume that you haven't watched that yet. Maybe you're just dealing with an engine with a stepper motor and you've just chose to bypass that pulse width modulated solenoid training tutorial. So we're going to jump from our basics page here and let's go over into our idle area here. What we're going to do is set up some of our programming details to get familiar with stepper motors, and then we're going to talk about some of the basic procedures that we need to work with here to get things set up in terms of our base position table, in terms of our idle target RPM table, and then we'll talk about getting other parameters set up here in the idle actuator area. And then finally, at the end of the tutorial, we'll introduce our idle ignition control. This is what's going to be that fast path of control for manipulating the engine's torque. This is the fine adjustment to keep us really close to the target. Again, the airflow that we're working with from a stepper motor, that slow path of torque control, that's going to be slow moving. And we'll find that that's going to be just something that we want to kind of have in place. So in terms of that stepper not really moving a whole lot, getting that coarse airflow, that base airflow for the engine's torque production kind of established. And then we use the spark timing feedback to dynamically control things and keep us at the target. Okay, so what we're going to do here is go up into mode, and we're going to have our options here between open or closed loop control. Now, we can tune the idle stepper motor in open or closed loop. I would recommend to put it in a closed loop. What this is going to allow the Link to do is take a look at the base position table. This is the feed forward position or feed forward value. It's going to start from for its control, and then we're going to be allowing some programming here to allow the Link to feedback and either increase or decrease from our base step position to get our idle correct, to get that airflow, that kind of coarse airflow adjustment correct. So I'm going to go and use closed loop as the option here. Again, I think this works the best. Let's click OK. It's going to ask me, do you want to go ahead and clear some of these tables out? I'll click yes. Now, what we need to note about this is that the idle base position table, when we go ahead and click that yes option, that it's showing idle base position here, and that the idle target RPM table is showing the idle target right here. So sometimes if you go ahead and these tables were zeroed out, so they just were kind of blanked out, and then you populate them, sometimes it'll start to put some kind of an odd table in here. Sometimes you see idle base position populated here, as well as idle base position populated here. If you're finding that's the case, then you're gonna have to go over here to ECU settings, and then you're gonna have to unlock whatever table that's not correct. Jump down in here. If we take a look down in idle speed control, you'll have to double click on your little grid icon to populate the correct table in the correct window. It's a software glitch. I noticed it happens sometimes. It didn't look like it happened here, but it did happen in that pulse width modulated tutorial. I just quickly showed how to go ahead and populate the tables to make sure they're the correct table for the correct area that we're editing. Okay, so the next thing we're going to do here, now that we have these two tables up, we're going to go in here to our actuator type, and we're going to double click. And now we find we have the ability to select solenoid, which is pulse width modulated option, 3-wire solenoid, which is also pulse width modulated. We talked about all that. Stepper motor is what we want to select here. E-throttle is our other option. We will have a separate training module on e-throttle drive-by-wire control for idle control tuning. That is, in my opinion, the best option of all of these, but let's assume we're sticking with what the engine has been fitted from the manufacturer with.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.